Welcome to the next concept under variations of graph called the reciprocal function. As you can see, I prepared a table over here because you are in for a treat. Okay, there's a lot of things over here to observe. But to introduce this concept to you, right? Over here, what I've done is that I've gone to Desmos and I have plotted a very random graph, right? And this graph over here is a cubic graph, right? Not really a cubic, but it's a reciprocal graph. And below, I've actually sketched or rather plotted the reciprocal function, which is 1 over the original graph. Right, so just to begin, just to introduce, a reciprocal function means 1 over the original function. So if the original function is fx, the reciprocal of fx would be 1 over fx. So as you can see over here, the original graph is this, and the reciprocal is below. So if I show you the reciprocal, right, if I turn this on, you can see that the reciprocal function, it looks vastly different from the original function, right? And that is because of the following rules that govern this change that we will be discussing right now. So you can see that the table over here I prepared contains many different things that will change when we have a reciprocal function. And don't know whether you see this as a good news or bad news, but you have to remember this by heart. Okay, but the thing is that as a math student, right, I didn't love to memorize things. So what I did was I tried to understand every single thing that was happening underneath the hood so that it made sense to me so that I didn't have to memorize it. So in this case, I will try to explain it, how each and every one of this works to you so that it makes sense to you as well and you have an easier time remembering these concepts during the exam. Okay, so now let's say on my original curve, right, y equals to fx, I have a maximum point. And let's say this maximum point it happens at, let's say, a comma b, right? In the reciprocal function, what I'm doing is that I'm taking the y value and 1 over the y value, right? So the maximum point, the x coordinate will not be affected at all because I'm not doing anything to the x value, right? We are just changing the y value, but the x value still remains as a. And now the y value will now become 1 over the original value, right? 1 over the original function, 1 over the original value. So now this one will become 1 over b. But the important thing to note over here is that a maximum point will then transform into a minimum point. Okay, now it becomes a minimum point on the reciprocal function. So if let's say originally is 1 comma 5, when I transform it, it becomes 1 over 5. And from a max point, it now becomes a min point on the reciprocal function. A min point, right? Because you see that the original value is 5 and now it becomes so small to become 1 over 5. So from such a big value to such a small value, it goes from being the maximum to now becoming the minimum, and vice versa for a min point. So let's say my minimum point originally is a comma b, right? Originally. Now, same change, right? I just take the b value, 1 over b, because I apply the reciprocal function. And now it inverts. It becomes a max point. Okay, but now it's a maximum point. Just take note of that. Next, horizontal asymptote. So a horizontal asymptote is one that looks like that, right? We have a straight line like that. And then this is y equals to something. So let's say I have a horizontal asymptote of y equals to 8. When I apply the modulus function, it will still be a horizontal asymptote, but now it will just be 1 over 8, right? It's still a horizontal asymptote. So I'm just going to indicate here, still a horizontal asymptote, right? It's still, but it's just that the value will change slightly. So originally, let's say it's 5, now it's 1 over 5, okay? Next, vertical asymptote. So let's say originally I have a vertical asymptote over here at x equals to, let's say, b, for instance. What happens to this vertical asymptote? Okay, so I want you to remember this analogy. This vertical asymptote, right, it happens at a value of x equals to b, and the y value, the so-called y value of this asymptote is infinite. Right, this vertical asymptote, it goes up, it goes down infinitely. So the y value for this asymptote actually approaches plus minus infinity, original vertical asymptote. So the only way for us to achieve plus minus infinity in math, you can just remember it as taking a number divided by 0, right? The only way for us to achieve infinity in math, or a very simple way to think about it, is to take a random number, let's say a, divide by infinity, divide by 0, because in math you cannot divide anything by 0, correct? So we can therefore say that the so-called the y value of this line is a over 0, which is essentially plus minus infinity, because anything divided by 0 is infinity. So when we have a over 0 and now we apply the reciprocal 1 over than the original value of a over 0. It now becomes 0 over a, right? Because 1 divided by a fraction, we flip it, it becomes 0 over a. And therefore, 0 over a will have a value of 0, because if you take 0 divided by anything, you get 0. So now the y value becomes 0 instead, or plus minus infinity, while the x value doesn't change. So if the x value is still b and the y value is now 0, that means on the graph, now it becomes a x-intercept, where it's x, or rather it's b comma 0. So now the change is that it becomes a x-intercept. That's the change that has happened, right? So we go from a vertical asymptote to a x-intercept. All right, next, for a oblique asymptote, let's say y equals to mx plus c originally. Now when we take mx plus c over here, right, and we actually stretch it until it's ridiculously huge, right, because you see that this oblique asymptote, it carries on infinitely. So as x approaches plus minus infinity, like just like for this case over here, right, for this case, as x approaches plus minus infinity, then the y value will tend towards mx plus c, right? But then for this case over here, as x tends towards plus minus infinity, you realize that the denominator over here becomes very, very big, and y will actually tend towards 1 over, or rather it becomes 1 over something that is huge, right? Because now the mx plus c is in the denominator, and when you have a very huge value, or when you have 1 divided by a very huge value, you can say that y actually tends towards 0. So in short, what happens to a oblique asymptote in a reciprocal function is just that, I'm just going to make some space for myself. I'm just going to bring this here. What happens is you get a flat line of y equals to 0. So it transforms, it becomes y equals to 0. So any oblique asymptote becomes y equals to 0. Okay? So just a recap, max point become mean point become max point, horizontal asymptote remains as horizontal asymptote, vertical asymptote becomes an x-intercept, oblique asymptote becomes y equals to 0, a flat line, just like that. Alright, next, above the x-axis, any graph that is originally above the x-axis, for instance, like that, right? In this case over here, it stays above the x-axis. So it remains above the x-axis for this case over here. Okay, so you won't need to flip anything. What belongs on top belongs on top, what belongs below belongs below. So anything below the x-axis, it stays below the x-axis. Next, x-intercept. So let's say originally I have an x-intercept over here, right? And then let's say this is a comma 0. A comma 0, we can imagine it as a comma 0 over 1, right? Because 0 divided by anything is 0. So let's say now we apply a reciprocal, right? When we apply the reciprocal, what happens is that it becomes 1 over 0, because you realize that from here to here, we flip the fraction. And when we flip the fraction, because we apply the reciprocal, it becomes 1 over 0. And 1 over 0 is yet again plus minus infinity, right? So an x-intercept at a comma 0 will now become a vertical asymptote, which is x equals to 8, because now it will tend towards plus minus infinity. Okay, so this is our vertical asymptote. Okay, so let me just share a story real quick. This, when I was in JC, I had the hardest of times trying to memorize this, and it only made sense to me when I view it this way, when I could explain it in my own words and reason out to myself why x-intercepts becomes a vertical asymptote and why a vertical asymptote becomes x-intercept over here. Okay, so I'm really hoping that this analogy makes sense to you. Okay, and next we have a y-intercept. So y-intercept, quite straightforward. Let's say originally here is 0 comma b. When we apply the reciprocal, it will still be here, right? It will still be a y-intercept, but now it's 1 over b. So still a y-intercept. Okay, all right. Next, just a normal point, right? A normal, let me change this, normal point. Just a normal random point of a comma b, right? It will be a normal point as well. But now the normal point will be a comma 1 over b. No change. Okay, so as long as it's not a max point, mean point, just a normal point, it will remain as a normal point. Okay, lastly, graphing behavior. This one is very important. So in a graph, okay, let me just illustrate this over here. There are 4 different kinds of behaviors. We can have 1, 2, let me draw like that. And let's say I have another one that is going to here. Okay, let's say I have one that's like that, and then like that. Okay, yeah. So there are 4 portions, or rather 4 different types of graphing behaviors. 1, 2, just going to draw a dotted line here. 3, 4. Number 1 is the graph. Okay, so fx, the graph, is actually approaching positive infinity. That's the first kind of behavior that we can observe in the graph, right? fx is actually approaching positive infinity. The second kind is number 2, whereby fx is actually approaching positive 0. Okay, the third kind is over here, where fx is actually approaching negative 0. So it's approaching positive 0 for number 2 because, you know, it's approaching 0 but it's still on the positive side. Whereas for number 3, it's approaching 0 but it's still on the negative side. And then we have number 4, whereby fx, oh wait, let me erase this and draw the correct one, like that. Yeah, it should be going down. So this is the fourth portion, right? And then the fourth portion over here is when fx is actually approaching negative infinity. So there are 4 portions of 4 different graphing behaviors that we can typically observe in any graph, right? So when we apply a reciprocal, what happens? So I'm just going to draw the reciprocal over here. So when fx is approaching positive infinity, right, the reciprocal of it will approach positive 0. So now instead of it going up, it will now approach positive 0. So it will now approach positive 0. So this is number 1 case over here, right? A direct transformation. Now for number 2, when it's approaching positive 0 over here, it will now approach positive infinity. Okay, that's the change. Now for number 3, when it is approaching negative 0, it will now approach negative infinity. This is for number 3. And for number 4, when it's approaching negative infinity, it will now approach negative 0. Okay, so it still complies with the rules that we mentioned earlier, which is anything above the x-axis stays above the x-axis, anything below the x-axis stays below the x-axis, right? You can see that this one, it stays above, it stays above, it stays below, it stays below. But if it's going up, it will now come down. If it's going down, it will now go up. If it's going up, it will now come down. And then if it's going down, it will now come up. Right, we always read from left to right. So we read the graph as going down, coming up, going down, coming up. Okay, so to summarize what I just said earlier, I'm just going to write it here. Okay, if fx is approaching positive infinity, 1 over fx will approach positive 0. If fx is approaching positive 0, 1 over fx will now do the opposite and approach positive infinity. Okay, just writing below now. If fx is approaching negative infinity, 1 over fx approach negative 0. And lastly, if fx approaches negative 0, 1 over fx will approach negative infinity. So same part of the y-axis, right? If it's positive, you stay positive. If it's negative, you stay negative. But the direction in which it's headed in will now be different. Okay, so that's the whole idea behind this whole reciprocal graph. Okay, so it's been a very long video, but this is everything that you need to know in terms of basic concepts for this portion. So once we are done, now we are done with this, you can head on to try and tackle this question over here and try to sketch for yourself the reciprocal graph based on what we have gone through so far. Feel free to pause this to go and tackle this question right now. And when you're ready, come back and let's see how the answer is actually being derived. So you might be a little bit confused when you are sketching this reciprocal graph, especially for the first time. So let me teach you, how I will actually analyze this. Okay, so first thing is I will mark out all the very critical points. One here, one here, one here, one here, right? That's the first thing I'll do. The second thing I'll do is to mark out the critical regions of the graph as well. So this is going towards negative 0. This portion is actually going towards a positive infinity, right? In that direction. This one is going downwards towards positive 0. In fact, this whole portion of the graph is going towards positive 0. And then this whole portion is actually going towards positive infinity, right? So I can visually mark out the 4 main portions of this graph, right? So this is part 1, then this is part 2, this is part 3, and this part 4, right? 1, 2, 3, 4. So if I were to sketch it right below over here, this is how it will look like. First thing is that this x-intercept of negative 2, I know that now it will become a vertical asymptote over here, right? There will be a vertical asymptote over here at negative 2 over here, right? Next, so this is done. Next, at the maximum point of negative 1, 7, I would expect there to be a minimum point of 1 over 7 over here now, right? So that is fixed. Next, I have a y-intercept of 4 over here, and that would mean that I will have another y-intercept over here at 1 over 4, right? Or rather, yeah, here will be 1/4. Take note that since 1 over 7 is at this height over here, then 1 over 4 should be on top of it, right? Then next, I have a minimum point of 2 over 5 over here. So that means that I should have a maximum point over here at 5 over 2, right? When I flip it. And now it's a maximum point. So now this is settled. So the next thing would be to adjust according to how the graph is progressing. So for this first portion over here, I see that the graph is actually approaching -0. So what that means is that before, since it's approaching -0, it will now approach -infinity, right? It stays below and it goes in the opposite direction. So that means now it will go down like that, right? Because here is approaching -0. So now it will approach -infinity. Now for the next portion, since it's approaching +infinity, it should now be approaching +0. Right now it should be approaching +0. That's why from here it comes down to the minimum point over here, right? Because now it's approaching, not saying it's going towards, but the general direction is towards +0, right? And then for the next portion over here, so now this is done, now this is done. For this portion over here of the graph is actually going towards +0. So now for a change, it will go upwards, right? Now it will, for this graph, it will approach +infinity instead. So now from here, it shoots up until here, right? Where now the graph is going upwards. And then for this last portion over here is going towards +infinity. So now it will approach +0 instead. So now it will go downwards. Oops, I mean that's a little bit steep. Let me try. It approach +0. Note that it doesn't go down to 0, right? It approaches it. That's why I never let it cut the line, because it still fundamentally has to stay in the positive region over here. So fundamentally it still has to stay above the x-axis, right? And that would be it for the reciprocal graph function. So this is how we actually sketch it. Okay, so practice makes perfect. Let me know if you got any other questions. Leave it in the comments below, or you can text me on WhatsApp. If not, try out one more question for yourself. Try to sketch this graph over here and see whether you're able to do it. And once you are ready, feel free to pause this video, come back and attempt this question. Alright, so I hope that your attempt at this was slightly easier than the previous one. Let's analyze this first and see about the important things that we need to actually, take note of sketching. So first thing, I see that there's quite a lot of asymptotes. We have a horizontal asymptote, we have a vertical asymptote, as well we have an oblique asymptote. So we have the full set of asymptotes. Next, we also have a maximum point over here, and lastly we have intercepts over here. So this graph over here is really quite a lot to sketch, right? And not only that, we still have to also identify what are the different regions of the graph. So we can see this is the first portion. It's actually approaching -0, and then it reaches a maximum point. So over there it's flat, and then after that it actually goes down towards -infinity. So this is the second portion of the graph. Now for the third portion of the graph, is actually approaching -0, right? And then for the last portion of the graph, is actually approaching +infinity. So now we need to effectively sketch all the 4 different portions, as well as all the asymptotes and your intercepts. So let's do this one by one. Okay, so the best way to approach this would be to do things in an orderly manner. Let's first sketch out the asymptotes. So y equals to 2 would mean that we will have an asymptote over here at y equals to 1/2, right? Because you have 1/. Next, with a oblique asymptote, so now this is out of the game. Oblique asymptote, remember, it approaches 0, right? Because you have 1/x plus 1, and then as this value in the bottom gets very big, the whole fraction effectively approaches 0. So apart from this, we also have a asymptote over here, which is y equals to 0. Another asymptote over there, right? And now this is out of the picture. Next, we have originally we have a vertical asymptote x equals to 1. That means now we have a x-intercept over here at 1,0. So now this is settled as well. Okay, next over here we have a x-intercept over here at 1.5, right here. So that means we will have now a vertical asymptote at x equals to 1.5. I'm just going to make some space. Yeah, we're going to have a vertical asymptote at x equals to 1.5. So now this is settled as well. Next, originally we have a y-intercept at -1. So -1/1, 1/-1 will just give me back -1. So no change here. This is still -1 over here, right? Over here is still -1, no change there. So what I can do over here is I can just take this off. Okay, next, over here originally is -0.5. So when I have 1/-0.5, it turns out to be -2, right? And since here originally was a maximum point, that means I will have a minimum point now here at -1, -2 over here instead, right? The -1 still remains up, so that is settled as well. So I have effectively done up all the asymptotes, and I've also done up the intercepts. So what's left is to draw out the 4 different portions of the original graph: up, down, up, up. So the first portion that is actually approaching -0 will be the portion that actually approaches -infinity, right? And we have to follow the asymptote. So since this original portion of the graph was following the oblique asymptote, and now the oblique asymptote is now y equals to 0, that means now it will still follow the new oblique asymptote, which is y equals to 0, and it will go downwards towards -infinity, because originally it's approaching -0, 0, now it will approach negative infinity. So now it will go downwards like that. Okay, so that's the first portion. It approaches negative infinity. By the way, you don't need to write all this down in your working. This one you don't need to write. At the end of the day, you just need to sketch it and label all the critical points. But I'm just writing this over here for you to understand what's going on. But at the end of the day, you just need to make sure that your graph looks something like that, right? When you present your answer to the examiner. Okay, next. This portion of the graph is going towards negative infinity, which means that now this graph has to approach negative 0. So from here, we will go up, cut the y-axis because over here there's a y-intercept, and then it will approach 0 over here. And since this graph originally tends towards the vertical asymptote over here, right? There's a vertical asymptote originally, and this graph was tending towards it, and now the vertical asymptote become an x-intercept. That means this graph will cut the x-intercept. Alright, next portion of the graph is actually approaching negative 0 yet again. Right, so since this portion of the graph is approaching negative 0, our reciprocal graph will now approach negative infinity. And lastly, this last portion of the graph is actually approaching positive infinity. That means now our final graph over here should be approaching positive 0. And that is the new graph over here, which is 1 over fx. Right? Wait, apologies. Let me just shift this up here. Right, it should be approaching the line of y equals to half, because the original graph over here is approaching the original asymptote of y equals to 2, right? So since it's approaching the original line of y equals to 2, this should still approach the original line, which is the new line of half over here, right? And with that said, that brings me to the end of this portion over here for reciprocal functions. Need a lot of practice, but you know, in the portal, in the library portal, we have a lot of practices. So please go and practice and hone your skills over there. The more you do it, the better you get at it. Any questions, feel free to reach out through WhatsApp. If not, I'll see you in the next video or the next chapter.